All right, hello and welcome to the solution of the astronaut holding the Coke can in space. All right, we have a 101 kilogram astronaut floating in space. So think about it. What forces are acting on him before anything happens? Zero, no forces. He is in equilibrium with uniform motion. But when the Coke can is opened, 10 newtons of force is applied to the Coke this way. Therefore, a force this way will be on the guy. All right? And that force will last for a total of 5 seconds. The question is, what will his acceleration be? And then after that 5 seconds, how fast will he be moving relative to his initial velocity? Let's look at the solution. First thing you want to do is you want to write down what you know, the givens in this problem. And in this problem, we know that the mass of the guy is 100 kilograms. So let's write that down to the left. The mass is equal to 101 kilograms. All right, we know that the force of the can is equal to 10 newtons. We also know that the time that that force is applied is equal to 5 seconds. All right, from this information, we need to find the acceleration. So the first thing you always do, figure out what we're looking for, acceleration. We're also looking for a change in velocity eventually. Okay, so there's our givens, there's our known. The next step is to draw a free body diagram. So, here it is. This dot represents the guy. Okay, the guy is the system. He's the thing experiencing the forces. All right. Think about it. What forces are acting on him while the Coke can is opened? He has one force, and it's pushing him this way, and we call it the force of the Coke can. Are there any other forces on him? No. So the next thing we do is we make a net force equation. The net force is the sum of all forces, and it's equal to the sum of all forces. And in this case, there's only one force, so it's simply equal to the force of the Coke can. All right? So you always do that. Your first step is purely symbolic. Your next step is you're going to start to open up the symbols. You're going to start to open up and see what's inside. All right, so what's inside of net force? Well, inside of net force is the mass of the system times the acceleration of the system. And that's going to equal what's inside the force of the Coke can, which inside is 10 newtons. All right, now we can plug in what we know. We know that the mass of the Coke can is the mass of the guy is 101 kilograms. Make sure you have your units. The acceleration is unknown, and that's going to equal 10 newtons. Solving for the acceleration then, acceleration is going to equal 10 newtons divided by 101 kilograms. And when you do that in your calculator, you end up getting 10 divided by 101, and you get 0.099. 0.099 meters per second squared. Awesome. So there is our acceleration. And now we can come over and write it here. 0.099 meters every second squared. All right, now we need to find the velocity. So all this work right here was to find the acceleration. Now we need to do the same thing, but find the velocity. All right, so what do? We do the same thing that we did to find the force, or find the acceleration. We set up equations. So we're looking for velocity, we know acceleration, we know time, we're looking for velocity. Well, if you recall, we know that the change in velocity is equal to acceleration times the change in time. That's one of the 4 equations of accelerated motion. And from here we know the acceleration, we just solved for it, 0.99 meters per second squared times a time of 5 seconds. So simply, if you're, think about it, you're accelerating, you're increasing your velocity by 0.99 meters per second every second, and you're doing that for 5 seconds. So you're going to multiply it by 5, and you're going to get out a total change in velocity of 0.4, actually it rounds up to 0.50 meters per second. So there is our velocity. Come over here, 0. Sorry about that. 0.50 meters per second. All right, and there we go. We have that problem completed.